Hi everyone and welcome back to Dev Portal, your go-to channel for mastering database concept. In today's video, we are going to discuss another query optimization technique which Postgres use, that is bitmap index scanning. If you ever run your query and seen bitmap index scanning or bitmap heap scan in your query planner and you are not aware of those terminologies, then this video is for you. So let's start our today's video. So first let's discuss what is an bitmap index scanning. It is an optimization technique which is used by Postgres when multiple indexes are involved. Let's say the query which you can see in my screen, it has fetching all the records of employees where full name equal to employee underscore 234 or salary equal to 4536. Now in that case, suppose two indexes are involved. In that case, what Postgres can do, it can use the bitmap index scanning. That is one scenario. Second scenario is that suppose let's say large number of rows are matching our condition, but those are not large enough to do the sequential scanning. In that case as well, Postgres can try to do the bitmap index scanning. And the last scenario is that is the third scenario, when Postgres want to avoid redundant heap access. So instead of scanning the heap for each index match that we usually doing in our index scanning, what Postgres will do, it will build a bitmap for the each row location, and then it will fetch all the relevant pages in the form of batches. So first we will discuss what are the key difference between index scanning and bitmap index scanning, and then we will go into our real world example. We are using our employees table where we are having 50 million records, so we will find out that how bitmap index scanning is helping us to fetch the records. So first let's discuss what are the key difference between index scanning and bitmap index scanning. If we talk about index scanning, then it will do the access row by row with the help of indexes, but that is not the case with the bitmap index scan. What it will generally do, first it will scan the entire index and it will create the bitmap, and later it will do the heap scan. That is one difference. Second difference is that with this what we understand, if we talk about index scanning, the heap access is immediate because we are going to the index, we are finding our condition, whichever is satisfying our condition, we will go to the leaf node, and from that leaf node we will go our heap, and from that heap we will fetch that page into our memory, that is buffer. So it means immediately we are hitting the heap, but that is not the case with the bitmap index scanning. First it will create the map and later it will go to the heap to avoid redundant heap access. And if we talk about index scanning, then it is applicable when fewer rows are matching. But if we talk about bitmap index scanning, it will applicable when multiple rows are matching but not those large enough so that it will go to the sequential scan. And the third, or you can say the last scenario, is that when multiple indexes are involved. In that case you will find that index scanning is not happening. It will only happen when we talk about bitmap index scanning. So when we talk about bitmap index scan, it means multiple indexes are also involved, but that is not the case with the index scanning. So these are the key difference between index scan and bitmap index scan. Now let's jump into our real world scenario and let's discuss that how bitmap index scanning will work internally. So the query, as you can see, first let me show you that how much data I have. So let's say suppose I have executed select let's say count 1 to show you that how much data is present in my employees table, and this data will come from tutorial.employees, and let me execute this query, and this will contain total 50 million records. Employees, let me add s as well, let me execute it again. Okay, tutorial, it is tutorial. So let me execute this query again, and it will take some time to fetch the total number of counts, or you can say the aggregate count which is present in the employees table. It is 50 million records, as you already aware if you are watching my previous tutorial as well, and we are going to work on this 50 million records. So here you can see total 50 million records is present in this table. Now what we are going to do, we are asking our Postgres database is that I want the detail of the employees, all the details that is exist in the DB where full name equal to employee underscore 234 or salary equal to 4536, and we will see with the help of our query planner what it is doing behind the scenes. So let's execute this query first, and as you can see it here, that here it is using bitmap index scanning, and there are multiple indexes are involved. You can see it here at line number 7 and 10. Two indexes are involved. One is full name salary index, another one is salary index. Let me go to the SQL as well of this table. So if I go to the tutorial, let me open table section, and this is the employees SQL. Let me open, and you can see it here. I have one index on full name and salary, that is the multi-column index, and another index is on salary. Now you will wonder that I have used full name and salary in my where condition. Why it is using another index? That is only because we have mentioned full name equal to employee underscore 234, that is one condition, and then we have mentioned or, which means either you will give me the record of this or salary equal to 4536 this. It means it is not the AND condition, that it will match our index that we have seen just now, that is full name and salary index, because when we are creating multi-column index it is applicable for AND condition. If I change this OR to AND, you will find that it will use index scanning. Let me show you. If I change it to AND, if I execute the same query again, you can see it is doing index scanning. Why? Because now it is easier for the Postgres to identify full name and salary, because it is storing both the values. But earlier what we are looking for, that is the full name or salary, which is can be applicable in one case, that is the full name, because full name is present in the left hand side of the index. As you can see it here, it is present on the left hand side. If I come down, or here you can see at line number 23, first full name is mentioned, then salary is mentioned. So it can utilize this index for the full name condition, but for salary what it can do? So if I go to the SQL again, you can see it here, another index is present, that is salary index. So for that index it will utilize to find out the salaries, where salary equal to 4536. So if I change this AND to OR again, you will find it will use bitmap index scanning. So this is the query planner. Now let's discuss, or we will go more deeper into this to understand that how it is working. So as I already told, at line number 10, it is using salary index, and you can see it here, actual rows that it has found is 0, which means there is no employee exist with the salary 4536. As you can see it here, actual time and row that is 0, and actual time it took, that is 0.007 milliseconds. And estimated, as you can see it here, it was estimating that 847 rows can be matched. Then if I go a little bit up, you can see another bitmap index scan that it has utilized on the full name salary index, that is used for the full name, where condition is employee underscore 234, and here as well you can see row is 1, which means one employee exists with this full name. You can see it here, row is 1, and earlier it has estimated row as well, that is 1. So estimation and the actual count, or you can see the actual result, is matching for a full name, but for a salary it was not matching. It has estimated that 847 rows can matched, but it has found only 0 rows are matching. And then you can see it here, buffer hit is 4. What does it means? That it has go to the memory and it has read the page 4 times for your this index and 4 times for your salary index. That is the meaning of buffer shared hit equal to 4, which means 4 times it has go to the memory and read the pages. And if I go a little bit up, you can see it here buffer hit is 8, and you can see one more thing at line number 5, that is BitmapOr. What does it means? Let me show you with the help of my Excel that I have created. So let's say in our example you can see 2 indexes are involved. Let's say it is index 1 and index 2. So how the things are working in bitmap index scan? So what actually happens behind the scene is that what Postgres will do, if we talk about index scanning, how it is working, that it is going to the index, it is trying to match the rows that which is satisfying the condition. If any condition got satisfied, it will go to the leaf node of that B tree, and from that leaf node it will identify where that tuple is present, that is the block, where that block is present, and which offset it is present, that is the page. So it will go to the heap, and from that heap it will load that page into the memory, and then it will extract the result, and other result it will wash out, or you can say filter out, that are other result which are not satisfying the condition in the pages, because multiple records are exist in same page. So that is happening in the index scan. Now let's say multiple condition are satisfying. So in that case what will happen? Multiple IO operation will involve. First our Postgres will go to the heap, that is not heap, it will go to the index. From that index it will find the matching condition, it will go to the heap, that is the IO operation. Then again it will come back to the index, try to find out another condition which will match. Then it is matching the condition, again it will go to the heap to collect that result, then again come back to the index. So this is the 2-flow operation that is happening, multiple IO operation are involved. Now as a developer, if I tell you this is the scenario which is working behind the scene, so ideally what you will do, you will think that how we can reduce this IO operation, because we are going multiple times to the heap to fetch the data. So what Postgres has done it here, what they have created a map of bit. What does it mean? Suppose let's say for block 0, here you can see that is block B, C, D. In Postgres it will be block 0, 1, 2, 3 in that form, and let's say the condition which will satisfy it will mark it as with the reference where it has to go, and the condition which is not satisfying, you can understand in a way that it is marking as a 0. What 0 means, that this is the condition which is not satisfying, or you can say the block which is not I have to visit. And for D it means that I have to visit this block according to the index 1. This is happening in index scan as well. What they are doing, they will directly jump into the heap, but here what we did, we created a bitmap and we are storing the result in that form, so that in future we know that which page we have to go or which block we have to visit. So for that we have marked 0, 0, 1, which means two conditions are satisfying for the index 1, and same way for the second index as well. What is happening, there are two conditions which is satisfying the result, or you can say the where condition. Now let's say in our case what is happening, it is doing bitmap or. So how bitmap or will work? So as we already aware in Java, what or will means, or in any programming language, what or will means that either this or this, it will reflect as a true condition. Either value A should be true or B should be true, any one will be true or both will be true. In that case it will be true. So how bitmap or will get created finally, if I go to Postgres again, you can see it here. It will create the bitmap or, and after that it will do the heap scanning. You can see it above, it will do the heap scanning later. First it will create the bitmap or. So how it will create bitmap or? It will match both the condition again, the bits that we have generated or we have scanned. So you can see 0, 0 which will result in 0, that is for bitmap or. 0, 1 which will result in 1, then 1, 0 will result in 1, 1, 1 will result in 1, then 0, 0 means 0 and 0, 0 means 0. This is for bitmap or. What will happen for bitmap and? Let's say bitmap and is also applicable in this scanning. So not in this example but in some other example. So in or and what will happen, that both the condition or all the conditions should be true. So you can see for B block it is 0, 0, 0, 0, 1 is 0, then 1, 0 is 0, and then 1, 1 is 1. So with this it is easier for us to understand that which all pages we have to visit in the heap and which all blocks we need to fetch. With this it will come so easier. If we talk about the scenario where index scanning is happening, how many times it will go to the heap? 1, 2, 3 and 4. But in our bitmap or, how many times it will go? That is 1, 2 and 3. And for bitmap and it will go only one time. So you can understand that how much IO operation we have reduced. So this is the benefit of bitmap scanning, that why Postgres is doing it, so that it can reduce the IO operation for your heap. So again go to the let's go to the Postgres. So we understood that what Postgres is doing behind the scene. First it will generate the bitmap for your each index, and then it will combine the condition based on what you have mentioned in your filter. We have mentioned or, so it is using bitmap or. It will generate the final map. If we have mentioned and, then it will generate bitmap and map. And finally it will do the heap block. Why? Because it has to fetch the data from the heap. But before that as well, it will check. You can see it here at line number 2. It is recheck condition. What does it means? Let's say from the map we understood that okay, this is the block we have to visit. If I go back, so here we can understand okay, these are the blocks we have to visit, but again it will recheck the condition because of the visibility. Let's say we have updated the result or any modification has happened that Postgres is not aware. You should not get those data which you are not looking for, or the you can say the data which is not belongs to the condition. So for that it will again do the rechecking, and then finally it will go to the heap. So if I go to the Postgres again, you can see it here. Finally it will do the heap scan on the bitmap heap scan. You can see it here, and the final output that it is mentioning is the row 1, that we already know that employee underscore 234 will exist in the system. So that row it will return to us. If I execute this query, you can see only one row will come. If I execute, you can see it here, only one data is coming. Let's say if I change the value to something, and if I execute it again, let's say how many records are coming. So it is still 1. So let me do one more thing. Let me write select all from tutorial dot employees, and let me give condition. Let's say id equal to 5. Let's see what is the salary of this employee. So it is the salary 25155. So we are using this salary now. Let's see 2 records will come or not. So let me execute this query again. So you can see it here, multiple records are coming, that is 820 records. Why? Because there are multiple employees exist with the same salary. So let me execute the entire query planner with the help of explain analyze. So now if I come down, you can see it here. For salary, it is mentioning that 819 rows are actual matching, and there is one employee with your full name as well that is matching the condition. We can do one more thing. Let's say if I execute this query, let's see what is the salary of this employee. So this is the salary. Let me copy this salary and let me paste it here. Now let's see what is the total actual result it is mentioning. So it is 865 rows and 1 row for this as well. So finally, how much rows it is returning? 865. So you can see how perfectly it is working. One employee that is exists with this full name, that is employee underscore 234, it also has same salary, but we have found for the employees that are having salary 70064, those are 865 employees. And finally it has done bitmap or, and you can see that is the redundant result. You can understand in this way that this is the redundant result in this condition, that is the block E. So your full name is also satisfying the condition, your salary is also satisfying the condition, but final result you are getting, that is 3 in this example, and you can see in Postgres that is 865 records. So this is how Postgres will work behind the scenes with your bitmap index scanning. Same thing will be applicable for your bitmap and as well. In that case, it will combine both the condition and then finally it will do the heap scan so that it can reduce the IO operations. So how effectively it can give you the result, you can imagine that it is the estimating time of is 34.420 milliseconds. But let's say if you are doing sequential scanning or index scanning, it can found that okay, if I do the index scanning, multiple IO operations are required. It may be possible that I will not give you the result as quickly as possible, or even with the help of sequential scan as well, it is not I am not able to give you the result quickly. But with the help of bitmap index scanning, I can do the parallel indexing or generating the parallel bitmaps for your multiple indexes. Then I can combine the result, and then finally I can do the heap scan and I can give you the result. So what is the benefit if you want to understand? That is it has reduced IO operation and boost the performance, because now there are many rows which are matching the condition, but we are not going to the heap every time. We will go to the heap in the final stage in the form of batches. We are not going to the heap from the index directly to the heap to fetch the record. We will generate a map, and then finally we will see which all pages we have to visit. We will visit and then we will extract those pages, and then we will find out our result set or the result that we are looking for. So this is all about bitmap index scanning. Now let's discuss when does Postgres will go for the bitmap index scanning. So first scenario is that when many rows are matching but those are not enough to do the sequential scan. In that case, what Postgres will do, it will do the bitmap index scanning. And when multiple indexes are involved, in that case as well, Postgres prefer to do bitmap index scanning because it can reduce the IO operation that we understood with this example. Another scenario when Postgres will do the bitmap index scanning is that when Postgres want to optimize your heap access with the help of batches, as we understood with the bitmap index scanning that it is doing the heap scan finally, and it can do with the help of batches. It can extract multiple pages in the form of batches because now it knows which all pages it has to visit. So to summarize, today we have discussed that what is a bitmap index scan in PostgreSQL and how it works internally. So that's it for today's video on Dev Portal. If you found this video helpful, don't forget to like this video, subscribe to Dev Portal and share these videos with your fellow developers and colleagues. Notes link I will give you in the description box as well as in the comment section, so you can check it out. And if you found my Git repo useful, please give it a star, and I will see you in my next video.